Hi everyone, in this video series I will talk about the friction model and definition that are available in STKO for OpenSees, and I will discuss about the Coulomb model. So let's call it friction model Coulomb, and let's call it A friction column friction model Coulomb. Sorry about the grammatical mistakes. So I will discuss what actually this definition is and what is the purpose of this Coulomb model in OpenSeas, right? So, and I will also talk about the value of coefficient of friction that is present in it, which is called mu, and name of this function, then how OpenSeas work in the background or back end of this modeling environment. So when we are trying to model two surfaces interaction or two entities that are separate from each other and they are coming into contact with each other, then there is a need of a behavior which take the surfaces to interact with each other and transfer the mechanical forces to each other. So that's why the friction model is important in STKO and OpenSeas. So when we are talking about the OpenSeas, the friction Coulomb model in OpenSeas sets between the coefficient of friction and the sliding velocity that is given in the documentation of OpenSeas as well. Here uh, you can find out here are the details, right? So basically, this command window that we are using here is from the OpenSeas documentation, and we need to understand the model, that what actually this model is and what does this represent in OpenSeas. So if you are using OpenSeas, then the syntax of the command is basically given here, that is friction model space Coulomb and then space dollar sign friction tag space dollar sign mu. Friction tag is a unique friction model object tag, and mu is coefficient of friction. So you can study about this in the example friction model Coulomb 1.0.163, and this is the behavior that is presented in this single graph here. So in case if you are using the STKO environment, so this is basically the tag that you are going to use here, and this is the new value or new value that you are going to use here. So this friction Coulomb model is a material model that is used in OpenSeas to simulate friction behavior between surfaces that are in contact with each other, and it captures the phenomena of sticking, I mean no slip until a certain force threshold is reached, followed by sliding with the constant friction resistance. And there are some key parameters that are present in the OpenSeas model in the back end of STKO. And let me just, you can directly access it from this region, and I already have opened the STKO, the OpenSeas document. So we can see here that what are the key parameters. So the first key parameter is the coefficient of friction that is dependent and we have the sliding velocity here. So this value, this coefficient of friction value, this represents the maximum resistant force that can be mobilized before sliding occurs, and it is expressed as a proportion of the normal force acting between the surfaces. While this sliding velocity that is present here, this represents the relative velocity between the two surfaces in contact. So this is not the velocity of the moving object. This is the velocity of the sliding of the surfaces here. So when the relative velocity is zero, this velocity, the relative velocity is zero between two surfaces. For example, two surfaces are in contact with each other. So the force transmitted is directly proportional to the coefficient of friction and the normal force. And when the sliding velocity increase, the transmitted force remain constant at a friction resistant nu multiplied by normal force, and this is because the model assumes contact friction during the sliding here. So for example, if you have a sliding force, like let's say you have two surfaces and there is a you have a sliding surfaces, sorry, a surfaces in this profile, and you have an object that is moving or sliding on it. So what does this represent basically? And this black is the surface in between these two models. So as soon as the relative motion of the sliding surfaces is same, then the model will be considered as a stuck model. But when the sliding occur, for example, if this is the direction of the force, so there is a resistant force here, and the surface actually have a feature that is represented with respect to nu. It is called the coefficient of friction, and this coefficient of friction is represented in this way. Right? So when the sliding velocity increase, that is in this direction, right, and the transmitted force remain constant at the friction resistance U, it means that a certain level is obtained at this coefficient of friction at which this model will not move further. So what happens if, for example, if this is the normal force, if we call it N, and this is tangential force here. And as soon as the normal and tangent, the relative surface, the relative motion is constant, then the sliding, it represents that the force is transmitted completely and proportional to the surface. However, when you start moving, the friction resistance remain constant to it reach and then become stable. So it does not transfer any further force here in the shear term. So if you are increasing the normal force, it will not resist it further, and the sliding will start occur here. So this is the sliding, and this is the mechanism it is occurring here. And they have represented it here in a very beautiful way. If the friction is high, it means that the surface that is present here, the maximum normal force is increasing for the right side, while the minimum normal force is for the green one. So there is a detailed discussion on this friction model. I'm not going to further discuss it. However, when you are working with OpenSees environment, I will discuss this in detail in OpenSees command as well, right? So when you are defining it in the STKO environment, uh, you have to define this friction coefficient. And the the model behavior, as I mentioned here, that if the relative velocity is zero, the model is stuck, and the force transmitted directly proportional to the coefficient of friction in the normal force, F is equal to nu n, right? If is if we consider the shear force, that will be directly force directly related to the normal force in this stage, and as soon as the friction is increased and the coefficient of friction is introduced in it, it will transfer to this stage here. So the sliding with the increasing the sliding velocity, the transmitted force remain constant at the friction resistance level nu multiplied by normal force, and this is because the model assumed constant friction during sliding here. So a question arises here at this point, that why it is in between the two. The friction Coulomb model basically captures the transmission of the forces between sticking and sliding behavior. This is a sticking and sliding behavior. If the coefficient of friction is present, so they define the maximum force that can be transmitted between these two surfaces that is present, while the sliding velocity indicates the state of motion here. So if the relative velocity is same, it means the sliding is not occurring and the friction is constant. However, if so the friction is increasing, however, after reaching at a certain point, this remain constant and the sliding velocity start increasing. So the model itself sits between these two parameters because it represents the relationship between the transmitted force and the sliding velocity. So if we talk about the sliding velocity, if this velocity is equal to zero, this is the relative velocity, right? If it is 0 meter per second, it means no motion is occurring here. So we have this stage of the curve that is present here. And if velocity, the sliding velocity is greater than 0 meter per second, right? So it means that the motion is occurring and this relative velocity is taking place in its role here. So the friction Coulomb model is a simplified representation of friction behavior, and it may not capture the complexity of the friction, such as variation in the coefficient of friction with sliding velocity or pressure. And that's why OpenSees offer other more sophisticated models that can account for these details. However, this is a simplified model that can be used in the OpenSees here. So um, this is a simplified model that is present in the OpenSea. So if you define it, most of the time, if we talk about the masonry and the steel, we define this to be zero point 0.3 here. So this is about the definition of the inclusion of this Coulomb friction definition in the STKO environment for OpenSeas. And when I'm demonstrating it in a practical example, I will explain it in a more decent way how we can include it in our modeling environment. The important thing is we should understand the terms that are associated with the STKO for OpenSeas so that we understand the behavior of the modeling environment. And after that, when we understand all these definitions, it means we have a clear idea of our modeling environment, and then we can start designing the practical examples on it and doing some validation steps, etc. on the STKO of our OpenSeas. And then it will be very easy for us to consider the OpenSeas as well. So yeah, it's very simple. Thank you for watching.